Chapter 14, the oceans, Section 14.5, El Nino, La Nina, and the Southern Oscillation. So El Nino is the name given to a cyclical development of warm ocean surface waters that develop along the coast of Ecuador and Peru. And this water extends along the equatorial Pacific, sometimes all the way across the ocean basin. El Nino usually occurs around Christmas and can last from a few weeks to a few months to a couple of years. Extremely warm events develop and last for more than a year. Since 1935, there have been strong El Ninos in 1941, 1978, 1983, 1987, 1992, 1998, 2010, and the last one in 2016. It's interesting to note that El Ninos have such an effect on the Earth atmosphere system that they actually cause global mean temperatures to rise. And many of the high points in the temperature record, global temperature record, are associated with El Nino events. So let's look at a normal cross-section at the equator along the equatorial Pacific. And what normally occurs is we get the following circulation system: a high pressure system that develops off the coast of South America, Peru, Ecuador, and a low pressure system off the coast of Indonesia. This initiates the following circulation system and creates moderate trade winds that blow from South America to Indonesia. These winds cause a flow of seawater, warm seawater, to go from off the coast of South America to Indonesia, and they bring up moderate cold water upwelling because of the Ekman spiral, Ekman transport along the coast of Peru. In an El Nino, the pressure patterns change. Instead of a low existing over Indonesia, another high develops, and the low moves to the center of the equatorial Pacific. This pressure pattern weakens the trade winds. The trade winds become weaker, and results in a reverse in the direction of the warm seawater. Now it's moving from Indonesia to South America. Sea level drops near Indonesia, rises over South America, and we can see from satellite imagery that the water at the sea surface in the Pacific at the equator is warmer than normal. So here I've created a surface temperature anomaly map associated with some of the major El Nino events since 1940. So an event in 41, 58, 1966, 73, 78, 1983, 1987, 1992, 1998, 2003, and 2016. So this map measures the anomaly in temperature that is created by an El Nino event. So as I said, remember, along the equatorial Pacific, it creates a tongue of warm water, and we can see that with the yellow-orange color that exists at that location. So that water is warmer, or that location, the surface temperature, is warmer than normal. White indicates normal, so normal temperatures exist. And what El Nino and La Nina do is they create temperature changes in other places besides the equatorial Pacific, and we call these changes teleconnections. So for example, you can see that when El Nino occurs, and we're looking at December to March, that's the months when when they occur. It creates abnormally warm temperatures along the western coast of North America, centered on about southern BC, Washington State. It also creates cold temperatures we can see in Siberia, and so on. So these are some of the teleconnections. Here is another diagram that shows the global effects. So as I said, warm along the from Alaska down to Oregon, Washington State. Cool, wet weather in southeastern United States. Dry weather in eastern Brazil. Warm and wet weather along the equatorial Pacific. Dry, warm weather in South Africa. Warm weather in Southeast Asia, and so on. So here we see a satellite image of El Nino occurring October 22nd, 2015. So it started early. This is part of the 2016 El Nino. And you can see the warm tongue of water along the equatorial Pacific, extending from just off of in the Pacific Ocean, off of Indonesia, and moving towards the coast of South America. And you can see the warm temperatures it created all along the west coast of North America. So this event went from October 22nd, or went from fall 2015 into spring 2016, peaking in the winter months. La Nina is name given to the cyclical development of cold ocean surface waters along the coast of Ecuador and Peru. Once again, occurs around Christmas, usually lasts for a few weeks to a few months, but extreme events can last for more than 1 year, sometimes up to 2 years. Strong La Ninas have occurred in 1939, 1950, 1971, 1974, 1976, 2008, and 2011. And in fact, we have La Nina occurring right now in 2020-21. So in a cross-section, what happens in a La Nina is the trade winds become very strong. There's that circulation system which looks like the system that normally occurs is intensified and much stronger flow patterns. It results in strong cold upwelling along the coast of Peru and a strong cold pulse of seawater moving from South America to Indonesia. So here are some of the temperature effects associated with La Nina. So it creates cold temperatures along from Alaska down to California. In our parts, it creates cold temperatures and a lot more snow. And so once again, remember, we're looking at December to March for the time frame. It creates warm temperatures in southeastern United States. Previous events have had temperatures warm temperatures that extended all the way into Ontario and Quebec. So here's another diagram showing the effects. So you can see cool temperatures along from Alaska down into Oregon and extending into North America. Warm and dry in southeastern United States, northern Mexico. Cool and dry along the equator in the Pacific. Wet in eastern Brazil. Wet in Indonesia. Wet and cool in South Africa, and so on. What's really interesting about El Nino and La Nina is, while they're slightly different, they each time they occur, they seem to produce the same sort of effects climatically in terms of temperature and changes in precipitation. So here is the sort of timeline of El Nino and La Nina going back from about 2018 to 1930. And so you can see the cyclical nature of these events. And this is an index, so the higher the value on the index, the stronger the La Nina or El Nino event. And as I said, El Nino tends to be associated with variations in global temperature that are higher than the baseline, and La Nina tend to create global temperatures that are lower than the baseline or best fit line through the data. So here we've identified some of the major El Nino events. You can see they show up at peak temperatures, and the blue represents some of the La Nina events.